Thank you all for coming along, and I hope you're having a good day. So I'm actually going to start with a short story. This is Emily Events, or at least it is until I can think of a better name for her. But apart from having a slightly strange name, Emily is a developer, and she's just started a new job. And the first task she has in her new job is to add a consumer to an event and update a third-party API. And she thinks, well, look at me, I'm called Events. I'm going to be really good at this. So she goes to her team and she says, where do I find details about all our events? Well, that's a bit tricky. They're all SNS topics. They all have the prefix of event, or most of them do anyway. So what we'd usually do is go to the AWS console and search and find them. And she thinks, that's not great, but she goes and does it, and she finds a few hundred events or topics, and she finds a couple that she thinks maybe she could use, maybe is the ones she's looking for. So she goes back to the team, and she says, how do I find the payloads for these events? And her team say, well, it's a bit tricky. We either check the source code that produces them, or sometimes we even have to create a Lambda function to subscribe to the topic, log it to the console, and find them in CloudWatch. And again, she's not overly enamored by this, but she goes into GitHub, and she finds some code, and she finds what those events, the payloads for those events, but it doesn't have the data she needs. So that's okay, she thinks. I'll create a new version of this event. So she goes to the team. How do I create versions of events? Well, we don't really do versioning of events. Probably just create another topic and produce to that. So, okay then, I'll do that. So she starts writing the code, and she thinks, hang on a minute, I don't know what the structure of these events are. And she goes back to the team, and she says, what's the standard structure for your events? I say, well, we've kind of got a sort of a standard, but lots of people add things to it and ignore it. And she finds a few sort of examples that look a bit like that for the schemas. So she thinks, okay, I'll copy some of those. And she goes off. She writes the code to produce it, produces a pull request, and the senior engineer has just come back from holiday, and he's obviously not very nice because he finds out the event already exists, it just didn't have the right prefix, and basically she wasted all this time. So she's a little bit frustrated, but we'll leave her there for now and maybe come back later. So my name's Chris. As well as being an AWS community builder, I am also a senior engineer at Trustpilot, and one of the projects I've been working on is to make sure that if Emily came to work at Trustpilot, she wouldn't have any of those problems. So just very quickly, if you haven't heard of Trustpilot, I need to get this bit right because it's been recorded, isn't it? We are the world's largest independent feedback platform. And at the beginning of the year, we had around about 300 million reviews. So most of the examples I'm going to be giving are around reviews. But that's kind of all the context you need to know. So what am I going to talk about? So we're going to look at exactly why we're doing this. And then we're going to see what it is we're trying to achieve from this project. We're going to how we're doing it. We'll look at the actual implementations, how we went through the implementation, and look at the impact that it is having / should have. We'll see. So why are we doing it? We've got 280 unique events. We produce around about 30 million events a day. Maybe it's a bit more now, I think, since I did that slide. The whole thing is underpinning a successful FTSE 250 company. So, why are we doing it? So, we had an architecture review last year, and one of the things we noticed when we were drawing up the diagrams was that this massive list of SNS topics for these cross-domain events. I could show you the diagram, but it crashes my browser, so I can't actually show that. But we've got this massive list, and it was thought that the cognitive load to understand what's going on there was too high. So that's where the project came from. And at the same time, we thought, well, we can handle these developer experience things that I mentioned earlier. So, I mean, I kind of exaggerated Emily's problems, let's be honest. But, you know, we do have some difficult to find events, payloads, standards are very loose, transfer patterns, and we have limited observability. And so, as a for instance, if we had a consumer that was consuming more than one event, this wouldn't be dissimilar to something we'd see. It's only getting the review ID, but it's getting it from various different places because various different events are put in a different place. Okay, so what are we actually trying to achieve? So the very first thing, we want some discoverability. We want a single place to find the events and the payloads. We want to know where they were produced from. We want to make sure that's valid and up to date. We don't just want me going and writing a document now and then come back in 12 months and it being out of date. We wanted some governance. So we're going to create a standard message envelope. We want some versioning. And we want to use the same transfer pattern as all the way across the board. And finally, observability. So observability, massive subject. For this project, we want to trace an event. So we want to view the producer, we want to view all the consumers, we want to know what data is in that event. And most importantly of all, we don't want to lose any data. I guess if you're a business and you lost a 5-star review because we were doing this, you probably wouldn't be that happy. If it's a 1-star, you probably would. But either way, we're not in the business of losing reviews, or any other data for that matter. So this came along to my team, and my first thought was, great, we'll move everything to EventBridge. We've got all these great things, we've got schema registry, we can use the direct integrations, do all of this, we'll move everything to EventBridge. And then it kind of dawned on me, we've got a few thousand consumers all looking for SNS, and it probably wasn't a great use of anybody's time just to do this because I like EventBridge. I mean, I do, but probably not enough to be able to convince everybody that we needed to do that. So also, we've actually got our own schema registry, so even that we didn't need. So we stuck with SNS. So how are we doing it? So to start with, we would look something like this. We might have a number of event topics subscribed to by various different consumers, usually lambdas, some getting more than one. And we thought, well, hang on a minute. Would it be a good idea to have a single topic per domain? And the reason per domain rather than across the whole organization, because we wanted to ensure that only producers in that domain could produce to it. And so we could set the IAM role to only allow the correct producers. Whereas if we'd gone across the whole organization, anything could have written to it and it wouldn't have been great. So, okay, so if we do that, we're actually slightly worse off because on the left, we can search through, as I showed earlier, we can search through the AWS console and find the events. On here, we can't, but of course, we're going to change that. So, what else are we doing? So it turned out we had Confluent Schema Registry already because we're using Kafka in some of our data products. So we can store our schemas through there. We can expose, the data teams are currently exposing that through Acro Data Hub, so we can do that. And earlier this year, the event catalog added support for Schema Registry. So we're also looking at maybe using that as well. So that's how we're doing our discoverability. So what about some governance? So I said we're going to have a standard message envelope. I said we have a loose-ish standard at the moment. So we've based the standard envelope on what our loose standard is, except we're going to make it less loose. So we've added an ID, a unique ID per event. We've got a timestamp. We've got the event name. We've got the payload, and we've got a version. And our version is done semantic versioning, so if I'm subscribing to version 1, I can be sure that my consumer isn't going to break. And we're going to produce all of these different versions whenever we produce the event. And we're not going to have anything else in the envelope. Next up, the transfer pattern. So at the moment, we're generally using the event notification pattern, where you just pass the ID of the object, and then it's up to the consumers to use that and get the data. That causes a lot of internal API traffic. For instance, it wasn't that long ago, we were having Dynamo tables throttling because a number of consumers were making the same call to an API just using the ID. And as far as I can tell, the conventional wisdom of people who know a lot more about this than me is that the event carriage transfer pattern is better for cross-domain events. And so we fill out the whole event. So, for instance, there we've got a review, we've got an email, we might have the business that the review's for. And so, unless we've got a very good reason not to, we're using that pattern. So finally, we go to observability. So we are currently transforming our observability from one provider to another, and traces aren't available to us just yet. I presented some of this in March over a Zoom call, and I said, I believe it's going to be available in the second half of the year, and I got lots of Zoom messages saying, you'll be lucky. So we thought we'd better do something about that and maybe add something in the interim. And so we've got an AWS account, so why not use X-Ray? And so we are. But we don't want to write code specifically for X-Ray and then have to change it later on. There is a great library for open telemetry, and that supports many, many different observability providers, both of which are the ones we want. So we've gone with open telemetry, and we can go to X-Ray, and then we can change the config at a later date when we need to. So that's how we're going to do it. But we've been through and implemented this, so let's have a look how we did it. So this was how we started. So we'd have an API. It would be publishing to each separate topic for the consumers, right? So the API is doing all the work. We want to go to a single topic. Okay, nice and simple. Except, so I've just spoken that we're going to create loads of different versions. We're going to go and get loads of different data. Doing that in a synchronous API call is probably not a great idea. We're going to add lots of latency. We're going to probably fail for no good reason, because some provider's down that we only need for the event. So we can make this asynchronous by quite simply putting a SQS and a Lambda there. So that producer Lambda gets knowledge of the schemas. It gets knowledge of the versioning. It gets knowledge of where to get all the data from. And that sits in that producer. It's triggered by the SQS, and then it produces various different versions of those events onto that topic. So this might be a schema, for instance. We use TypeScript, and we're using a library called Zod. And so a schema would look something like this: an ID, a version, a timestamp, an event name, and then a payload with whatever's in there. That's what it looks like, but we said we want to publish those into schema registry. And if the Lambda knows about it, we need to make sure that schema registry knows about it. So we deploy our Lambda via GitHub There's a bit of CloudFormation in the middle, but we don't need to worry about that for this. So we've added a GitHub action, and it will check the differences. And if there's any differences, it will update the schema registry. And so as long as our Lambda is validating against our schemas, then schema registry must be up to date, right? But haven't we done this the wrong way around? Shouldn't we actually be storing them in schema registry and letting the Lambda get it from there? Very possibly. The reason we haven't was because at the time we started this project, we didn't have access to the schema registry. And so we did it this way around, but I actually quite like it. So we'll see whether we actually change it or not, but that's why. And so our GitHub action does something like this. So yeah, this takes the Zod schema. It converts it to Avro using a tool called Advertise, and then that gets pushed to schema registry. That's fine. So I said, that as long as we're validating what we put onto that SNS, we're okay. So how do we ensure that we're validating it? So up until very recently, the only tool that we had doing this was me doing a code review. Now, I'm sure my team would agree that I'm a tool, but they would probably also say that I'm not very scalable. So there's this new thing you may have heard of called AI. I'm not sure it's going to catch on, but we're using that to do code reviews. So we're using GitHub Copilot. We're giving it some instructions like this, and it will go away. It will make sure that our schemas are as we expect them to be, and we can also get it to make sure that we're calling the validation function before we publish. And so we get code review comments like that, which is fine and far more polite than mine were that we saw at the start. Okay, so at this point, we're publishing both events. We want to move those consumers over to the new one, but first, we wanted to make sure that we were actually producing what we thought we were producing, that the events in the old version were the same as the one in the new. So to do that, we added a Lambda to subscribe to everything, wrote everything to an S3 bucket, and then we were able to use Athena to query that the old ones and the new ones were the same amount, they were the same data, they were the same events. And that was absolutely fine. So that's cool. So once we've validated that, we want to move those subscribers. But in order to not lose events, we can't switch them over straight away. We need to subscribe to both at once. So to do that, we need to make a couple of changes. So we need to update that consumer to pass both event formats. We said we've changed the format, so we need to do that. We need to ensure it's idempotent, and then we can add our subscription. So when we're looking at passing event formats, this might be a typical piece of code that takes the ID, goes and gets the review, and goes and gets the business for the review. So we add some complexity in here, because we need to do something different depending on where that message has come from. We will simplify it later, but yeah, we just basically do that. And then we need to think about idempotency. So if we get the same message twice, the same event twice, do we behave in the same way? Does it cause problems? Now, as you can see on the slide, SNS already only guarantees at least once delivery. And we're already using SNS for these consumers, so they should be idempotent, right? And the vast majority were, whether by accident or by design, I'm going to say design, but I may be wrong. There were some that weren't, mainly due to third parties, and so we had to do something to handle those. So what we did was we pushed the creation of that unique ID back from the producer Lambda into the API when it's pushing these messages. And therefore, if you were getting the same event, it would have the same ID. It wouldn't have the same payload, it wouldn't have the same format, but it would have the same ID. And then we could use, I think we used Lambda Power Tools to check that ID when we processed it. And so at that point, we were happy. We were using both. We subscribed our other consumers, subscribed the consumers to the newer event, and our subscription would look something like this. So we'd filter it by the event name and the version. We could filter it by the rest of the message if we want, the rest of the body. So if we wanted to only get specific pieces of data, because we're now using a different transfer pattern, we could do that. But most of the time, it's these. And so at that point, we're getting both events, we're handling them both, so then we can start taking things down. So, first thing we did was updated the subscription filter from the consumers to the old topics so that the data never got there. That was our first thing. Once we're happy there, we then take the API, stop it producing the old topics. Then we can remove all of the old topics, and we get to what we wanted for our target. We've got an API, we've got a producer, we've got a single topic per event, and then we've got our consumers subscribing based on well, usually event name and version, but based on whatever they want. And then, finally, we can update those consumers and remove any form of complexity in that code whatsoever, and extract the data like that. And so that's how we did that part. So now we come to the tracing. So my very limited understanding of OpenTelemetry is that it does something like this. So there's an OpenTelemetry collector. It collects the data, and then it pushes to whichever platform we've configured. So to do that from our producer, we can add a Lambda layer. So we've added the Lambda layer. That handles everything for us. We get all this out of the box. We give the Lambda permission to publish to X-ray in this case, because we're using X-ray. And away it goes. And it publishes. And so we get something that looks kind of like this. So yeah, we've got a producer on the left. We've got our event topic, our SNS topic. And then we've got the different consumers. So we've got an SQS to a Lambda. And we've got a couple of Lambdas. And we get that out of the box. And we can also see a timeline. Same kind of thing. It's just, yeah, by the timeline. And so that's all out of the box. But the one thing we haven't added is any kind of event payload to any of this. So what we can do, and what we do, is when we publish that event, we can extract the span from OpenTelemetry. We can use that. We can set the data, set attributes on that span. Then that data's there, and we can use that. And then one day, sometime soon, hopefully, especially since X-ray is being deprecated, we'll be able to change our environment variables on the Lambda, and it will write to our new provider. I can't say whether that actually works or not at the moment, because we've not done it. But that's what I'm told, so I've no reason to not think that. Okay, so what impact is some of this having? So it is easier to reason with. I mean, it's kind of anecdotal, this kind of thing, but we've had 2, 3 new engineers on our team, and they found it very, very easy to work with. I started 2.5 years ago, and I didn't find it that easy to work with, so I'm going to assume that it is easy to reason with. We are reducing the internal traffic. We haven't updated all consumers to not make those API calls just yet, but the ones we have, and then obviously anything new, we're not making our internal API calls at all. And again, reduction in development time for some projects. Again, I recently worked with some of these, and I did it far quicker than I would have done previously. So that's the kind of impact that all this has had. So what exactly did we do? Just in summary, we replaced a single topic per event with a topic per domain. We added schema registry to make our events discoverable. We introduced a standard message envelope. We've added versioning. We did tracing using OpenTelemetry, and we didn't lose anything, which is always good. And so, yeah, that's what we've been doing. Now, I started with the story, so I'm going to have to finish that story off. We need a happy ending, right? So we left our hero. She was very, very, very frustrated. And not surprisingly, she decided to quit her job. But she came and joined Trustpilot. And amazingly enough, the first ticket that she worked on was to add a consumer to an event, take that data, and publish it and post it to a third-party API. And so she came along, and she went straight to schema registry. And she found the event she needed. She found the schema. She added the consumer. She didn't need to make any internal API calls because all the data she needed was there. She made a few transformations. She posted it to the API. And she didn't need to do anything to implement observability because it was already there for her. And as such, she lived happily ever after. You can't finish a story without that, can we? So yeah, thank you very much for coming along. That's me on LinkedIn. I won't be offended if you don't connect. Yeah, so thanks very much.